nomenclature and formulas PowerPoint, and we're going to do naming binary covalent compounds. This is very, very easy. Covalent compounds, especially binary ones. You're going to use prefixes to identify what the subscript is. You don't ever see any Roman numerals used because we don't have any charges dealing with. We're dealing with compounds that are sharing electrons. The ending stays the same, and the second element changes to IDE. We don't ever use mono on the first element. If it's necessary, we'll use it on the second, but you never use it on the first. You never hear anybody say that humans exhale monocarbon dioxide. Now we just say carbon dioxide, so you never see mono put on the first element. All of the prefixes are going to be used, though, so mono is the only exception. So if we take a look here, we have carbon, and we have oxygen. So we're going to write carbon as is without changing the ending. We do not put mono on the first one. And we see that there is a 2 on the oxygen, so that prefix for 2 is di. And then oxygen changes to oxide, not oxygi, as I had some students do it. So just oxide. So there's your answer, carbon dioxide. Then we have CO, very similar to CO2. So carbon, again, we start off. Now, you got to remember here, again, no mono on the first one, but on the second one, regardless of what the prefix is, you always put it on there. So what do we see here? Well, we see nothing. If there's nothing there, that's understood to be a 1. So mono is the prefix for 1. And we don't write 2 vowels in a row. We drop one of the vowels. Otherwise, it would be monoxide, which just doesn't sound right. So carbon monoxide is the answer there. H2O, of course, that's water. So we have hydrogen. But what prefix do we see on? Or what subscript do we see on hydrogen? We see a 2. What's the prefix for 2? Di. So really, this H should not be capitalized. So dihydrogen. And then the O has a 1, understood 1, so mono oxide, but we drop the O, and we get monoxide. So there's your fancy name for water, dihydrogen monoxide. N4P7, so now we have a 4 for the nitrogen, so that's tetra. We do not change the name of the first element, so tetranitrogen. And then 7, hepta, is the prefix for 7. And then phosphorus changes to phosphide, not phosphoride. Again, that's just something you have to get used to. Next example, we see a 2, so that's di. And then sulfur, we don't change the ending, so disulfur. And then the 9 has a prefix of nona or nana. And fluorine changes to fluoride. So disulfur nonafluoride. And then Cl8Br3. 8 has the prefix octa. Chlorine, we don't change the ending, so octachlorine. Tri is our prefix for 3, and bromine changes to bromide. By the way, these aren't necessarily true compounds. These are just made up ones. So if you are looking at these thinking, well, these don't exist, well, that's not the point. I'm just trying to teach the prefix to the formula to name conversion. So try not to worry about it there. Binary acids. Well, how do we identify acids? We know that they start with a what? And we said in class they start with an H, excluding water and hydrogen peroxide. So how do we know something's a binary acid? Well, it'll just be H followed by one other element. That makes it a binary. So how are we going to name that? Well, we have to put hydro in the front, and then we always end it with ic, and in between the hydro and the ic is going to be whatever element is attached to the hydrogen. So we see HF. I know that's a binary acid because it only has 2 elements and it starts with an H. And I know it's going to start with hydro. Always start our binary acids with hydro. And then I know it's going to end in ic, so fluorine changes to fluoric. And then, of course, we have to throw the word acid on the end as well. So hydrofluoric acid would be our answer there. H2S. Well, again, we have a binary acid, only 2 elements. It starts with an H, so we know it's an acid. So it's going to start with hydro. And then sulfur. In this one, we don't drop any part of the sulfur. We keep all of it. And we just add the IC, sulfuric. So it's not hydrosulfic, it's hydrosulfuric acid. There's your answer to the second one. H3N. Again, binary acid because there's only 2 elements and it starts with H. So we know hydro is going to be at the beginning. Nitrogen changes to nitric, not nitrogic. And then we throw acid on the end there. So hydronitric acid is our answer there. And then HBr, again, we have bromine as our attachment. We know it's going to start with hydro, so hydrobromic acid. All right, that's part 8 of nomenclatures and formulas. I'll start with part 9 soon.